Standing in the shadow of a towering stone circle, you can almost feel the weight of time pressing down on you. These ancient structures, some older than the pyramids, don't just mark the landscape, they whisper secrets. What if I told you that the stones around you aren't just monuments to forgotten gods or burial sites for long-dead kings? What if there's something far more extraordinary, a prehistoric supercomputer, a celestial clock carved in rock, a mathematical code left behind by people who understood the cosmos in ways we're only just beginning to grasp? That's the mystery we're diving into today, the encrypted mathematics of megalithic timekeeping. Think about the last time you checked your phone for the date or the time. Now imagine tracking the movement of the sun, the moon, and the stars without paper, without metal tools, without even a written language. That's exactly what the builders of places like Stonehenge, Newgrange, and Göbekli Tepe did. They didn't just stack rocks, they engineered precision alignments to capture the solstice sunrise, the lunar standstill, even eclipses. These weren't random acts of reverence, they were acts of calculation, of deep astronomical insight encoded into stone. And somehow, these ancient architects managed to do it with a level of accuracy that still stuns modern researchers. So how did they do it? What kind of knowledge did they possess? And why does it still matter today? That's the journey we're about to take. From the rolling hills of Britain to the misty valleys of Ireland, from the sun-baked plains of Turkey to the forgotten corners of Peru, we'll follow the trail of these megalithic mathematicians. We'll decode their hidden ratios, their celestial alignments, their uncanny understanding of geometry, all buried in plain sight, waiting for us to piece it together. This isn't just about ancient history, it's about rediscovering a lost way of seeing the world, one that connects us to the stars, the earth, and the passage of time itself. Ready to unravel the mystery, let's begin. Standing among the towering stones of Stonehenge or gazing into the dark passage of Newgrange, it's hard not to wonder what drove ancient people to move these colossal rocks, some weighing as much as 50 tons, across miles of rugged landscape. The sheer effort alone suggests these structures held immense significance. For centuries, archaeologists assumed they were tombs or temples, places to honor the dead or worship the gods. But as we've studied them more closely, a different picture has emerged. These megaliths might have been something far more precise. Ancient observatories, their stones positioned like the hands of a cosmic clock, marking time in ways we're only just beginning to understand. Take Newgrange, for example. Built over 5,000 years ago in Ireland, this massive circular mound isn't just a burial site, it's a meticulously engineered solstice marker. Every year around December 21st, sunlight streams through a narrow opening above the entrance, creeping down the long passageway until it illuminates the inner chamber. This isn't a lucky accident. The builders calculated the angle of the winter sun with astonishing accuracy, ensuring the alignment would hold true for millennia. And they weren't alone. From the Karnak stones in France to the Mnajdra temple in Malta, similar structures reveal an obsession with tracking celestial events, solstices, equinoxes, even the moon's more subtle cycles. But why? Why go to such extraordinary lengths to map the heavens? One theory suggests these early societies were deeply tied to agriculture, relying on precise calendars to know when to plant and harvest. Another possibility is that these alignments held spiritual meaning, bridging the earthly and the divine. Yet the most fascinating idea is that these builders possessed a sophisticated grasp of mathematics and astronomy, knowledge we once thought impossible for their time. The stones at Stonehenge, arranged in perfect circles and arcs, encode geometric ratios like the Pythagorean theorem centuries before Pythagoras was born. The shapes and angles found in megalithic sites across Europe suggest a shared system of measurement, hinting at a network of communication or trade we've yet to fully uncover. What's truly remarkable is how these structures endure, their alignment still accurate after thousands of years. The megaliths weren't just built for their own time. They were designed to outlast generations, a testament to a civilization that thought in spans far beyond a single human life. And that raises another question. If they could plan with such foresight, what else did they know that we've forgotten? As we peel back the layers of these ancient sites, we're not just uncovering stones, we're rediscovering a lost science, one that wove together the movements of the sky and the earth in ways we're only beginning to decipher. Look up at the night sky, and you're seeing the same stars that guided the builders of these ancient stone monuments thousands of years ago. But they didn't just gaze at the heavens, they studied them, measured them, and built their world around them. The alignment of megalithic sites with celestial events isn't just poetic. It's a testament to an advanced understanding of astronomy that defies our assumptions about prehistoric cultures. Take the winter solstice sunrise at Newgrange, where sunlight pierces the darkness of the inner chamber like a laser. This wasn't guesswork. It required generations of careful observation, noting how the sun's position shifted minutely each day until it reached its southernmost point in the sky. The builders didn't just mark the solstice, they engineered a structure to capture it, down to the exact angle of the passageway, and they weren't alone. At Machu in Scotland, another passage tomb aligns with the setting sun of the winter solstice, flooding its interior with light. Across the Atlantic, at Choco Canyon in New Mexico, the ancestral pueblones carved spiral petroglyphs that interact with sunlight patterns during equinoxes and solstices. These weren't isolated experiments, they were part of a global pattern of celestial observation. But why focus so intently on the solstices? For agrarian societies, these moments were critical. They signaled the turning of the seasons, the time to plant or harvest. Yet the precision goes beyond practicality. At Stonehenge, the heel stone frames the summer solstice sunrise, but the site also tracks the moon's extremes during the 18-6-year lunar standstill. The builders didn't just want to predict the seasons, they sought to harmonize their world with the rhythms of the cosmos. The real marvel is how they achieved this without written records or modern tools. They likely used simple but effective methods, staking wooden poles to mark the sun's path, observing shadows cast by standing stones, or even using water surfaces as primitive horizons to track celestial movements. At Callanish in Scotland, the stones form a cross-shaped pattern that aligns with the moon's southernmost rising point during its standstill. This level of precision suggests a culture that didn't just watch the sky but mapped it, turning stone into a permanent record of celestial mechanics. What's even more striking is how these alignments persist across vast distances and cultures. From the dolmens of Korea to the stone circles of Senegal, similar principles emerge, structures oriented to catch the first light of the solstice or the rising of a particular star. This hints at either a shared ancestral knowledge or an independent discovery of the same celestial truths, and it raises a tantalizing question. Did these ancient astronomers communicate with one another, or were they all tapping into a universal understanding of the sky's patterns? The answer may lie in the stones themselves. At sites like Nabta Playa in Egypt, megaliths align not just with the sun but with the brightest stars in the night sky. These builders weren't just marking time, they were creating a cosmic blueprint, embedding their knowledge in a language of stone and light. And as we decode these alignments today, we're not just uncovering ancient astronomy, we're rediscovering a lost way of seeing our place in the universe. The stones of these ancient monuments don't just stand in random arrangements, they whisper a language of numbers, angles, and precise measurements. When we look closely at sites like Stonehenge, we find geometry carved into the landscape long before the Greeks formalized it. The inner circle of blue stones, for example, forms a near-perfect rectangle with sides that follow Pythagorean triples, those special ratios where the squares of two numbers add up to the square of a third, like 3, 4, 5. This isn't just coincidence. These proportions repeat across megalithic sites, hinting at a shared system of measurement and design that predates recorded history by thousands of years. But how could ancient builders have known these mathematical principles without written records or formal education? One theory points to the natural world. Early societies observed repeating patterns in everything from branching trees to spiral seashells patterns that echo the golden ratio and Fibonacci sequences. By replicating these shapes in stone, they may have stumbled upon universal mathematical truths. At Newgrange, the intricate spiral carvings covering the entrance stone aren't just art. They could represent celestial cycles or even early attempts to map logarithmic spirals found in nature. The precision goes beyond simple shapes. At the Ring of Brodgar in Scotland, the circular layout aligns with solar and lunar events, but the spacing between stones suggests an understanding of advanced geometry. Archaeologists have noted that many megalithic circles use a standard unit of measurement now called the megalithic yard, approximately 2.72 feet. This unit appears in monuments hundreds of miles apart, implying a network of knowledge sharing or a lost civilization's influence. Imagine the coordination required to maintain such consistency across vast distances without modern tools or communication. Perhaps the most compelling evidence lies in the angles. The sides of the Great Pyramid of Giza, often grouped with megalithic achievements, align almost perfectly with the cardinal directions, a feat requiring astronomical observation and geometric mastery. Similarly, the entrance passages of many megalithic tombs slope upward at precise angles, calculated to capture the sun's rays on specific dates. These aren't rough estimates. They're engineered solutions refined over generations. What's startling is how these mathematical ideas emerge independently across cultures. The pyramids of Egypt, the mounds of North America, and the stone circles of Europe all encode similar principles: right angles, sacred ratios, and celestial alignments. This suggests either a shared ancestral knowledge or a universal human instinct to quantify the world through geometry. The builders didn't just see stones, they saw equations, turning the earth itself into a canvas for their calculations. Yet the biggest mystery remains: why encode this knowledge in stone? Unlike scrolls or tablets, megaliths endure. They resist decay, fire, and time, preserving their messages across millennia. Maybe these structures were more than calendars or temples. Maybe they were textbooks, meant to teach future generations the language of the cosmos. As we measure their angles and decode their ratios today, we're not just studying ancient math, we're deciphering a lost science, one that sought to bridge the earthly and the eternal. Alexander Thom's discovery of the megalithic yard is one of archaeology's most tantalizing puzzles, a thread of consistency woven through the chaos of prehistoric Europe. Picture this: a unit of measurement, roughly 2.72 feet, appearing again and again in stone circles separated by hundreds of miles and centuries. From the Ring of Brodgar in Scotland to the Karnak alignments in France, the same proportions emerge, as if an invisible hand guided the builders. Thom didn't just stumble upon this pattern. He meticulously surveyed over 600 sites, recording diameters, circumferences, and spacings with painstaking precision. The numbers didn't lie, they revealed a system. But how could such standardization exist across cultures with no known written communication? One theory suggests the megalithic yard was derived from something universal, the human body. Ancient measurements often tied to anatomy, the Egyptian cubit based on the forearm, the Roman foot approximating, well, a foot. Tom speculated the megalithic yard might have originated from pendulum lengths or astronomical observations, but the truth remains elusive. What's undeniable is the practicality. At Observatory, for instance, the outer stone circle's diameter measures precisely 40 megalithic yards, while the inner rings follow multiples of the same unit. This isn't random stacking, it's deliberate, almost algorithmic design. The implications are staggering. If disparate communities shared this unit, it hints at a network of knowledge exchange far more sophisticated than we've credited to Neolithic societies. Traders, pilgrims, or migrating builders could have carried the measurement across continents, embedding it in local traditions. Yet there's a more provocative possibility. What if the megalithic yard points to an even older, now vanished civilization? Plato's Atlantis might be a myth, but fringe researchers argue that a forgotten culture, advanced in mathematics and astronomy, could have seeded this knowledge before collapsing into obscurity. Mainstream archaeology remains skeptical, favoring incremental cultural diffusion over cataclysmic lost civilizations. But the data nags. In Brittany's Gavrini's tomb, carvings repeat lengths matching the megalithic yard, while Orkney's stones of Stenness align to its proportions. The consistency is too pronounced to dismiss as coincidence. Perhaps the answer lies in the stars. Some researchers propose the megalithic yard relates to Earth's dimensions, a fraction of the polar radius or a harmonic of planetary motion. If true, it would mean Neolithic builders didn't just measure land, they calibrated their world to the cosmos itself. The enigma lingers because the megalithic yard resists easy explanation. It's not just a measurement, it's a fingerprint of intent, a clue to how ancient minds quantified their universe. Whether it emerged from shared ritual, trade routes, or a deeper, lost wisdom, one thing is clear. These builders spoke a language of numbers, and we're only beginning to understand their vocabulary. Every stone circle, every aligned menhir, is another syllable in a conversation spanning millennia waiting for us to listen. Stonehenge stands as the ultimate testament to megalithic timekeeping, a silent sentinel on Salisbury Plain that has guarded its secrets for over 4,000 years. But look beyond its iconic silhouette, and you'll find a structure meticulously engineered to mirror the cosmos. Take the Aubrey holes, a ring of 56 pits encircling the monument. For decades, their purpose baffled researchers until astronomers noticed something extraordinary. 56 is precisely the number of years it takes for the moon to complete 3 full cycles of its most extreme positions in the sky, known as the lunar standstill. Coincidence unlikely. These holes may have functioned as a primitive counting system, with markers moved between them to predict eclipses or track the moon's erratic dance. Then there's the heel stone, standing solitary outside the main circle. At dawn on the summer solstice, the sun rises directly over its weathered surface, casting a long shadow into the heart of Stonehenge. This alignment isn't just symbolic, it's a precision-engineered calendar marker, but the sophistication doesn't stop there. The 4 station stones, positioned in a rectangle around the monument, align with the moon's southernmost rising and setting points during its 6-year cycle. These aren't random placements, they're deliberate mathematical anchors tying the structure to celestial rhythms. What's even more astonishing is how Stonehenge's builders accounted for subtle celestial quirks. The slight wobble in Earth's axis, called precession, gradually shifts stellar alignments over centuries, yet Stonehenge's sightlines remain accurate. This implies generations of observers meticulously adjusting their knowledge, passing down refinements to maintain the monument's cosmic fidelity. The sarsen stones, arranged in trilithons, form frames that capture specific celestial events, like a stone camera lens focusing on the heavens. But why go to such lengths? Some argue it was purely practical, a way to mark planting seasons or coordinate rituals. Others see a deeper purpose, a bridge between earth and sky, where the stones acted as conduits for celestial energy. The truth may lie in the numbers themselves. The ratio of Stonehenge's inner bluestone circle to its outer sarsen ring echoes Pythagorean geometry, while the spacing between stones reflects harmonic proportions found in nature. This wasn't just architecture, it was a three-dimensional equation, a codex written in stone and shadow. And let's not forget the enigmatic slaughter stone, once upright but now fallen. Recent studies suggest it may have marked the winter solstice sunset, mirroring the heel stone's summer function. Together, these alignments form a dual calendar, balancing solar and lunar cycles in a harmonious system. The builders didn't just observe the sky, they synchronized their world with it, turning Stonehenge into a colossal clock, its hands made of stone, its face the horizon. The real genius of Stonehenge lies in its adaptability. Unlike rigid modern calendars, it could accommodate variations in lunar and solar cycles, adjusting through movable markers or oral traditions. It's a reminder that ancient science wasn't inferior, just different, blending observation, intuition, and a profound connection to the natural world. As we decode its alignments today, we're not just uncovering an ancient calendar, we're glimpsing a worldview where time wasn't measured in minutes, but in the majestic sweep of celestial bodies across the sky. Newgrange isn't just a tomb, it's a meticulously engineered solar observatory, a stone time capsule designed to capture a single, fleeting moment of the year. At dawn on the winter solstice, the shortest day in the northern hemisphere, something extraordinary happens. A narrow beam of sunlight pierces through a perfectly aligned opening above the entrance, known as the roof box, and travels down the 60-foot passageway. For 17 mesmerizing minutes, the light floods the inner chamber, illuminating intricate spiral carvings that have lain in darkness for months. This isn't just a happy accident of architecture. It's a feat of precision that required generations of astronomical observation and exacting construction. The brilliance of Newgrange's design lies in its subtle details. The roof box isn't just a hole, it's carefully angled to account for the sun's low position in the winter sky, ensuring the light enters at the correct trajectory. The passage itself slopes upward, elevating the chamber to meet the rising sun. Even the thickness of the stones framing the opening was calculated to narrow the beam of light, creating a focused slit that acts like a celestial spotlight. Modern engineers have run simulations, and the margin for error is astonishingly small. A misalignment of just a few degrees or a shift in the passage length by a foot would have thrown the entire phenomenon off. But the magic doesn't stop with the solstice alignment. The walls of Newgrange are covered in enigmatic carvings, concentric circles, zigzags, and spirals that seem to pulse with hidden meaning. Some researchers believe these could represent celestial maps, marking the paths of the sun, moon, or even comets. Others suggest they encode mathematical concepts, like the Fibonacci sequence or the golden ratio, echoing patterns found in nature. One particularly striking theory proposes that the spirals mimic the movement of the sun during solstices, a kind of prehistoric animation when viewed by flickering torchlight. What's even more intriguing is how Newgrange fits into a broader landscape of astronomical knowledge. Nearby sites like Noath and Douth also feature solstice alignments, though less perfectly preserved. Together, they form part of the Brú na Bóinne complex, a Neolithic cathedral of sky worship and timekeeping. The builders didn't just construct isolated monuments, they orchestrated an entire sacred geography where hills, rivers, and stones worked in harmony with the heavens. The question remains, why go to such lengths to mark the winter solstice? For an agrarian society, this moment signaled the sun's rebirth, the promise that the days would lengthen and crops would grow again. But the effort invested suggests something deeper than mere practicality. The solstice light show may have been a ritual of renewal, a way to commune with ancestors believed to reside in the chamber. Or perhaps it was a cosmic contract, a way to ensure the sun's return through symbolic reenactment. Newgrange's true genius lies in its endurance. 5,000 years of storms, invasions, and erosion haven't dimmed its solstice miracle. Even today, a lucky few who win the annual lottery stand in that ancient chamber, watching the same light that Neolithic eyes once witnessed. It's a reminder that these builders weren't primitive, they were pioneers of a lost science, turning stone and sunlight into a timeless testament to human ingenuity. And as we study their work, we're left wondering, what other knowledge now forgotten might still be etched into those silent walls? Göbekli Tepe shatters everything we thought we knew about the timeline of human achievement. Buried beneath a Turkish hillside for 11,000 years, this sprawling complex of carved pillars predates Stonehenge by 6 millennia and the Great Pyramids by 7. But what makes it truly extraordinary isn't just its age. It's the possibility that these massive T-shaped stones might be the remnants of the world's first astronomical observatory. Look closely at the pillars and you'll notice something peculiar. Many are adorned with intricate carvings of animals, scorpions, foxes, birds, and snakes, but these aren't just random decorations. Researchers like Dr. Martin Sweatman have proposed that these creatures could represent constellations, mapping the night sky as it appeared over 10,000 years ago. The scorpion, for instance, might correspond to Scorpius, while the vulture could mirror the constellation we now call Lyra. Even more intriguing, some pillars seem to depict comets or meteor showers, with symbols resembling celestial bodies streaking across the stone. Then there's the layout itself. The circular enclosures of Göbekli Tepe aren't haphazard, they're arranged with deliberate precision. One pillar, known as the Vulture Stone, shows a series of carvings that some researchers interpret as a record of a catastrophic cometary impact around 10,900 BCE, an event that may have triggered the Younger Dryas cooling period. If true, this would mean the builders weren't just stargazers. They were chroniclers of cosmic disasters, preserving celestial events in stone for future generations. The sophistication doesn't stop there. The T-shaped pillars, some weighing over 16 tons, are positioned in ways that suggest alignments with solstices or equinoxes. Pillar 43, for example, features a carving of a fox that aligns with the position of the sun during the autumn equinox when viewed from a specific vantage point. These alignments hint at a culture that didn't just observe the sky, they integrated it into their architecture, turning stone into a permanent celestial calendar. But here's the real mystery. Göbekli Tepe was deliberately buried around 8000 BCE, filled in with tons of soil and debris. Why would a society go to such lengths to construct these monuments only to hide them? Some speculate it was a ritual act sealing away sacred knowledge. Others suggest the site's astronomical function became obsolete as the stars slowly shifted over millennia due to Earth's axial precession. Whatever the reason, the burial preserved the site almost perfectly, leaving us with an unparalleled snapshot of a lost world's ingenuity. What's most humbling is realizing how much we still don't know. The carvings at Göbekli Tepe remain untranslated, their meanings locked in symbols we've yet to decipher. Were they star maps, religious icons, or both? Did the builders use these pillars to predict eclipses or track the movement of planets? Every new excavation peels back another layer of mystery, revealing a prehistoric society whose grasp of the cosmos might rival our own in ways we're only beginning to comprehend. One thing is certain, these stones aren't just relics, they're a challenge, daring us to rethink the origins of human knowledge. While the sun's steady march across the sky marks our days and seasons, the moon's dance is far more complex, a rhythmic sway between extremes that repeats only once every 18.6 years. This phenomenon, known as the lunar standstill, was no secret to the builders of megalithic monuments. At sites like Callanish in Scotland's Outer Hebrides, the stones don't just frame the sunrise, they capture the moon at its most dramatic moments, when it pauses at the northern or southern edges of its path before reversing course. Picture standing among those weathered pillars as the moon skims impossibly low along the horizon, barely rising before it sets again. This isn't just a celestial quirk, it's a moment the builders carved into the landscape with stone. The precision required to track this cycle is staggering. Unlike the sun, which follows a predictable annual rhythm, the moon's path shifts slightly each month, with its extremes magnified over years. At Callanish, the central stone aligns with the southernmost moonrise during the major standstill, while the avenue of stones points to the northern extreme. The builders didn't just notice these patterns, they engineered monuments to amplify them, turning the landscape into a permanent witness to the moon's slow-motion pendulum swing. Similar alignments appear at Bryn Celli in Wales, where a passage grave's entrance frames the summer solstice moonrise, and at the Great House of Chimney Rock in Colorado, where ancestral Pueblones built towers to observe the lunar standstill. Why did these cultures invest so much effort in lunar tracking? The reasons may be as varied as the sites themselves. For coastal communities, the moon's pull-on tides dictated fishing and harvesting cycles. For others, the standstill might have held spiritual significance, a rare celestial event marking transitions between eras or summoning ancestral spirits. There's also a practical angle. Eclipses only occur when the moon crosses the sun's path near standstill points, making these alignments crucial for prediction. The crisscrossing shadows cast by stones like those at Ballacroy in Scotland could have served as early warning systems, signaling when the moon and sun were on a collision course in the sky. The real marvel is how these lunar markers endure. Modern astronomers using computer models have confirmed that Callanish's alignments would have been even more striking 5,000 years ago, when the moon's orbit tilted slightly differently. Yet the stones still capture the essence of the event, a testament to builders who thought in generational terms. Unlike solar alignments, which repeat yearly, lunar standstills demand patience a single observer might witness only 2 or 3 in a lifetime. This long-term perspective hints at a culture that recorded knowledge not in books, but in stone, passing down celestial wisdom through carefully curated landscapes. Perhaps the most haunting question is whether these lunar monuments were more than calendars. At the Temple of the Moon in Peru's Machu Picchu, a carved stone altar aligns with the southern standstill moon, bathing the ritual space in an otherworldly glow. Was this a place where the moon's power was believed to be strongest, or a classroom where initiates learn to read the sky's subtlest rhythms? The stones won't say. But their silent alignments remind us that the moon's slow dance wasn't just observed, it was revered, encoded into the very bones of the earth by people who understood time not as minutes or hours, but as the measured breath of the cosmos itself. Spirals carved into ancient stones might seem like simple decorations at first glance, but look closer. There's a hidden language in those curves. The triple spiral inside Newgrange's chamber, for instance, isn't just art. It mirrors mathematical patterns found throughout nature, from the unfurling of fern fronds to the whirl of galaxies. This isn't coincidence. These carvings could be prehistoric expressions of the golden ratio, a proportion where the smaller part relates to the larger as the larger relates to the whole, creating an endless loop of harmony. The same ratio appears in the Parthenon's dimensions and Da Vinci's Vitruvian Man, yet here it is, etched into Irish stone millennia earlier. But the mathematical fingerprints don't stop there. The concentric circles at Noth, another Neolithic marvel, resemble ripples in water, a visual echo of the Fibonacci sequence, where each number is the sum of the two before it. This sequence generates a spiral found in sunflower seeds, nautilus shells, and hurricane formations. Did megalithic artists stumble upon this pattern by observing nature, or did they grasp its underlying mathematics? The precision of these carvings suggests intention. At Gavrini's in Brittany, spirals interlock with geometric precision, their curves maintaining consistent ratios despite being carved freehand. What's truly fascinating is how these patterns transcend geography. The same spirals appear in the rock art of Utah's ancestral pueblones, the temples of Malta, and the burial mounds of Japan. This isn't just shared aesthetics, it's a recurring visual vocabulary. Some researchers propose these symbols acted as mnemonic devices, encoding astronomical knowledge or agricultural cycles in repeating motifs. Others see them as maps of energy flow, aligning sacred sites with Earth's magnetic fields. The most compelling theory connects these carvings to sound. When struck, many spiral-adorned stones produce resonant frequencies, suggesting the patterns might represent standing waves or harmonic intervals. Imagine chanting or drumming in a chamber like Newgrange, the sound waves interacting with the carvings to create a multisensory experience. The spirals could then be diagrams of vibration, merging math, music, and ritual into a single symbolic language. Yet the mystery lingers. Why would ancient cultures embed such advanced mathematics in art? Perhaps because numbers were never just tools, they were bridges between the tangible and the divine. The spiral doesn't merely depict a ratio, it embodies the cycle of seasons, the path of celestial bodies, the rhythm of life itself. In these carvings, we're not just seeing decoration, we're glimpsing a worldview where art and equation were inseparable, a testament to humanity's timeless urge to find order in the chaos of the cosmos. Stand in the center of a stone circle like Stonehenge or roll right on a quiet morning, and you might hear something unexpected, the wind humming through gaps in the stones, creating an eerie, almost musical resonance. But what if that sound wasn't accidental? What if these ancient builders intentionally designed their monuments to sing? Across Europe, researchers have discovered that many megaliths produce distinct tonal qualities when struck. The Neolithic chambers of Michaud in Scotland emit deep, bell-like tones, while the carved stones of Carnac in France vibrate at frequencies that seem to harmonize with natural rhythms. This isn't just folklore, it's physics. The density and composition of these stones, often chosen from specific quarries, create predictable acoustic effects, suggesting sound was no afterthought. The theory gains weight when you consider how sound interacts with architecture. At Newgrange, the corbelled roof of the inner chamber isn't just a marvel of engineering, it's an acoustic amplifier. Whispered words at the entrance can be heard clearly in the back, a phenomenon that would have magnified chants or drum beats during rituals. Even more intriguing, some stones resonate at frequencies matching the Schumann resonance, the natural electromagnetic pulse of Earth itself, around 7.83 Hz. Could these megaliths have been tuned to the planet's own vibration, creating a bridge between human ceremony and planetary rhythms? Then there's the connection to celestial cycles. At Callanish, certain stones produce tones that align with lunar periodicities when analyzed through modern software. The idea of a sonic calendar isn't as far-fetched as it sounds. Indigenous cultures from the Andes to Australia have used sound to track time. Think of the didgeridoo's cyclical drones mirroring seasonal changes. If oral traditions could encode astronomical knowledge, why not stone? The builders might have used rhythmic percussion or vocal harmonics to mark lunar phases or predict eclipses, turning sound into a living, breathing almanac. But the most tantalizing clue lies in the carvings. Spiral patterns found at sites like Gavrinis don't just resemble sound waves, they might literally map them. When researchers at the University of Huddersfield scanned these carvings with laser vibrometry, they found the patterns matched standing wave formations, the kind created when sound bounces between hard surfaces. It's as if the stones were designed to catch specific frequencies, turning the entire structure into a giant instrument. Imagine a shaman striking a pillar during the solstice, the resulting tone echoing through the chamber as sunlight floods in a multisensory ritual blending light, sound, and sacred geometry. The implications stretch beyond ritual. Sound can alter consciousness, a fact exploited by everything from monastic chant to modern binaural beats. If megaliths were sonic tools, they might have been used to induce trance states, enhancing visions or communal bonding. Or consider practical applications. Low-frequency sound can affect water flow, plant growth, even stone levitation in certain myths. Were these technologies harnessed for purposes we've yet to uncover? What's undeniable is the intentionality behind these acoustic features. From the ringing rocks of Pennsylvania to the harmonic chambers of Malta, the same principles emerge: stone chosen for its voice, spaces shaped for resonance. These builders didn't just see megaliths as static monuments, they experienced them as living systems, vibrating in tune with the earth and sky. As we listen to these ancient stones today, we're not just hearing echoes of the past, we're deciphering a forgotten science where mathematics wasn't just seen or counted, but felt in the bones and the blood, a language of vibration woven into the very fabric of the sacred landscape. Consider the sheer audacity of this idea. Prehistoric builders without satellites or GPS somehow understood the curvature of the earth and encoded that knowledge into their stone monuments. It sounds like science fiction, but the evidence is etched into the landscape itself. Take the Great Pyramid of Giza, positioned with its sides aligned almost perfectly to the cardinal directions, a feat requiring not just astronomical precision, but an awareness of planetary dimensions. Now draw an imaginary line from the pyramid northwest across the Mediterranean, and you'll hit Stonehenge almost dead center, the distance between them. Roughly 1/7 of Earth's circumference, a ratio that repeats in other ancient sites. Coincidence? Maybe, but when you find the same mathematical relationships in places separated by oceans and millennia, it starts to feel like something more. The builders didn't just work locally, they thought globally. In Egypt, the Pyramid of Khafre aligns with the Temple of Karnak along a ley line that extends to Stonehenge. In Peru, the Nazca lines point toward sacred mountains with uncanny accuracy, while the mound complexes of North America mirror celestial patterns found in Britain. These aren't isolated acts of reverence, they're pieces of a puzzle, suggesting a shared or rediscovered understanding of Earth's geometry. The key might lie in something called geodetic surveying, the science of measuring large portions of the planet's surface. Modern surveyors use theodolites and lasers, but ancient cultures might have relied on simpler tools, sighting rods, plumb bobs, and the stars themselves. One striking example is the alignment of the Callanish stones in Scotland with the Avebury complex in England and the Karnak stones in France. These sites form a near-perfect arc across the landscape, with spacing that corresponds to fractions of Earth's latitude. Even more astonishing, the angles between them match the tilt of Earth's axis during the Bronze Age. This implies the builders didn't just mark their local horizon, they mapped the planet's orientation in space. The same principle appears in the Americas, where the Hopewell earthworks in Ohio align with the winter solstice sunrise, while their counterparts in Mexico track the same event with identical precision. How could cultures separated by continents and centuries achieve such consistency? One theory points to a lost epoch of exploration, where seafaring civilizations traded not just goods but knowledge. The Phoenicians, for instance, were renowned navigators, but their maritime prowess might have been built on even older traditions. Another possibility is that certain astronomical truths, like the ratios between Earth's dimensions or the precession of the equinoxes, were independently discovered by cultures attuned to the natural world. The recurring use of pi and the golden ratio in monuments from Egypt to Cambodia suggests a universal human instinct to encode cosmic order into architecture. The most tantalizing clue lies in the numbers themselves. The Great Pyramid's height multiplied by 43,200 equals Earth's polar radius, while its perimeter matches a fraction of the equator's length. These ratios aren't just symbolic, they're functional, turning the pyramid into a scale model of the planet. Similarly, Stonehenge's lintel stones form a circle that, when adjusted for Earth's curvature, would appear perfectly level across miles. This level of precision implies a grasp of spherical geometry millennia before Pythagoras or Euclid. Were these monuments part of a global network, a kind of prehistoric internet of stone? Or did they emerge from a shared human impulse to reconcile the terrestrial and the celestial? Either way, the implications are profound. These builders didn't just shape rocks, they mapped the world, turning it into a canvas for their cosmic vision. And as we trace these ancient alignments today, we're not just studying history, we're rediscovering a lost science that saw Earth not as a flat expanse, but as a spinning sphere, its secrets written in stone and sky. What if ancient megalithic structures weren't just marking the passing of seasons, but were tracking time on a scale almost unimaginable to us today? Imagine a calendar that doesn't just count years but stretches across millennia, mapping the slow, cosmic wobble of Earth itself. This is the megalithic calendar hypothesis, a radical idea that suggests sites like Stonehenge and Newgrange were designed to monitor precession, the 26,000-year cycle caused by Earth's axis gradually tracing a circle in space. To put that into perspective, the last time Earth's axis pointed toward the same stars as it does today, woolly mammoths still roamed the plains. The notion that Neolithic builders could conceptualize such vast timescales rewrites our understanding of their intellectual world. Take the 33 stones of Stonehenge's Sarsen Circle. Some researchers argue they encode precessional math, each stone representing roughly 800 years, collectively spanning the full cycle. Then there's the curious case of the Observatory henge, where the outer bank's circumference matches a fraction of Earth's polar diameter, scaled down by a factor mirroring precessional timing. These aren't random numbers, they're deliberate choices echoing across continents. In Peru, the mysterious 13 towers of Chanquillo align with solar risings throughout the year, but their spacing also hints at longer cycles, as if marking chapters in a celestial story too vast for any single lifetime to witness. The real clincher lies in myth. Ancient texts like the Hindu Yuga system and the Greek Great Year describe cosmic cycles eerily close to 26,000 years, suggesting this knowledge wasn't confined to stone circles but permeated oral traditions worldwide. At Ireland's Loughcrew cairns, carvings depict spiral patterns that, when analyzed geometrically, resolve into ratios matching precessional fractions. Were these carvings mnemonic devices meant to preserve knowledge across generations? The builders likely never saw a full precessional cycle. No human could, yet they may have understood its rhythm. observing how star positions shifted over centuries like hands on a slow-moving clock. Critics argue this is pattern-seeking, projecting modern math onto ancient art, but consider this: precession alters the position of the North Star over time. Around 3000 BC, Thuban in Draco held that role, not Polaris. The alignment of certain megalithic passages with long-gone pole stars implies builders tracked these changes. At Misho in Orkney, the winter solstice sunset now enters the passage at a different angle than it did 4,000 years ago, a discrepancy matching precessional drift. Coincidence or proof they calibrated their monuments to cosmic time? The implications are staggering. If true, these structures weren't just calendars but time capsules meant to communicate with future civilizations. They challenge the stereotype of prehistoric people as simple farmers, revealing them instead as cosmic archivists, stitching celestial mechanics into the landscape. In an age before writing, they found a way to speak across epochs, using stone as their parchment and the sky as their ink. The question isn't just whether they understood precession, it's why they cared. Perhaps they saw time not as linear but cyclical, a wheel turning endlessly, with their stones as spokes connecting past, present, and future. As we decode these silent sentinels today, we're not just uncovering ancient astronomy, we're glimpsing a worldview where humanity's place in time was measured not in years, but in the patient dance of the stars. Etched into the weathered surfaces of ancient stones, cryptic symbols whisper secrets across millennia. The cup and ring marks found from Scotland to Portugal aren't just random scratches, they form intricate designs, with concentric circles connected by radiating lines like celestial spiderwebs. Some researchers believe these could be primitive star charts, mapping constellations as they appeared thousands of years ago. At Cairn T in Ireland's Loughcrew complex, a backstone engraved with cup marks aligns with the equinox sunrise, illuminating specific carvings as if highlighting entries in a stone almanac. The precision suggests these weren't idle doodles but a visual language, encoding everything from lunar cycles to sacred geometry. Then there are the zigzag patterns adorning stones at Newgrange and Gavrinis, their rhythmic peaks and troughs mirroring waveforms or seasonal fluctuations. Archaeoacoustics pioneer Paul Devereux discovered that many of these carvings cluster at points where the stones resonate most powerfully when struck, hinting at a synergy between sound and symbol. The undulating lines might represent energy flow, seismic activity, or even the path of the sun through the zodiac, a prehistoric infographic blending science and spirituality. Perhaps the most tantalizing carvings are the spirals, recurring across continents with mathematical consistency. The triple spiral inside Newgrange's chamber isn't just decorative. Its curves adhere closely to the golden ratio, a proportion found in everything from nautilus shells to galactic arms. At Bryn Celyn in Wales, a serpentine carving winds around a pillar, its coils matching the moon's nodal cycle, the 6-year wobble of its orbit. Were these spirals mnemonic devices helping oral cultures memorize complex astronomical data? Or did they serve as ritual portals, their hypnotic swirls guiding initiates into altered states? The mystery deepens with rarer symbols, like the checkerboard patterns at Noath or the lozenge motifs at Douth. These could represent weaving patterns, metaphors for the interconnectedness of life, or even early computational grids, akin to an abacus for tracking time. In the Orkney Islands, a stone slab from the Ness of Brodgar features a perfect five-pointed star, a shape requiring geometric sophistication long before Pythagoras. Decoding this symbolism isn't just an academic exercise. It's a bridge to understanding how Neolithic minds perceived reality. Unlike modern linear writing, these carvings likely operated on multiple levels, recording harvest cycles while simultaneously invoking myth, mapping the heavens while channeling ancestral voices. They remind us that for these builders, numbers weren't abstract concepts but living forces, woven into the very fabric of existence. Each chisel mark was a dialogue with the cosmos, a testament to humanity's eternal quest to find meaning in the patterns of the world. From the sprawling alignments of Karnak's standing stones in France to the precision-cut walls of Machu Picchu's Temple of the Sun, the echoes of megalithic design reverberate across continents and epochs. On the surface, these sites appear worlds apart, separated by oceans, languages, and millennia, yet their underlying blueprints whisper a startling consistency. Take the way Karnak's rows of men here stretch for miles like a stone army, their alignment mirroring the solstice sunrise. Then shift your gaze to Peru, where the Inca engineered their sacred city to capture the winter solstice light through carefully positioned windows. These cultures never met, never traded maps or tools, yet both arrived at the same solution, embedding celestial mathematics into stone. The parallels grow even more striking when you examine their geometries. In Brittany's Gavrini's tomb, spirals and zigzags carved into the walls resemble the same patterns found in Newgrange, Ireland, despite being built over 1,000 years earlier. Meanwhile, on the other side of the world, the ancestral Pueblones of Choco Canyon constructed their great houses with ratios matching Pythagorean triples, just like the architects of Stonehenge. How could societies with no known contact independently discover identical mathematical principles? One explanation lies in the universality of nature's patterns. The golden ratio appears in sunflower seeds and hurricane formations. The Fibonacci sequence governs branching trees and galaxy spirals. Perhaps these builders weren't copying each other, but rather copying the cosmos itself, arriving at the same truths by observing the same sky and earth. Yet some connections defy simple coincidence. The megalithic yard, that mysterious unit of measurement found in Scottish stone circles, also appears in the dimensions of Peru's Sacsayhuaman, where massive zigzag walls interlock with uncanny precision. And consider the global obsession with solstice alignments. From Egypt's Karnak Temple to Mexico's Pyramid of Kukulkan, the sun's extreme positions dictated architecture with near-identical fervor. Was this a case of parallel invention, or could there have been a lost thread of knowledge weaving these cultures together? Maritime archaeologists point to evidence of Bronze Age sea trade, while diffusionists speculate about forgotten explorers who mapped the world long before Columbus. The most compelling argument, though, may lie in humanity's shared cognitive toolkit, faced with the same challenges: tracking time, predicting seasons, honoring the divine. Cultures worldwide arrived at similar solutions. Stone circles, pyramids, and terraced temples might simply be the inevitable outcomes when human ingenuity meets celestial wonder. Whether through shared ancestry or shared inspiration, these megaliths stand as testament to a universal language, one written not in words but in angles, alignments, and the silent arithmetic of the stars. Their stones ask us to consider not just how they were built, but why their builders across oceans and ages all heard the same cosmic call. Picture a gathering at dawn, hundreds of people clustered around a stone circle as the first light of the solstice creeps over the horizon. This wasn't just a scientific observation, it was a shared experience, a moment where the entire community came together to witness the cosmos aligning with their carefully placed stones. Megalithic sites weren't merely cold, calculating machines tracking celestial movements. They were the beating hearts of their societies, places where timekeeping intertwined with ritual, agriculture, and the very fabric of communal life. Consider the harvest. For Neolithic farmers, survival depended on reading nature's cues, knowing when to plant, when to reap, when to store food for the lean months. The solstice alignments at places like Stonehenge or Newgrange weren't just astronomical feats. They were practical calendars signaling the turning of seasons with unerring accuracy. But these moments also became sacred, woven into the rhythm of daily life. When the winter solstice sun pierced the darkness of Newgrange's chamber, it wasn't just marking the shortest day, it was a promise of renewal, a reason to gather, feast, and honor the cycles that sustain them. The stones became more than markers, they were anchors of tradition, their alignments reinforcing the connection between the community and the land that fed them. The social power of these sites went deeper. Building a megalith wasn't a solo endeavor, it required cooperation on a massive scale, quarrying stones, transporting them across miles, raising them into precise formations. These were collective acts that bound people together. Imagine the teamwork needed to haul a 50-ton sarsen stone to Stonehenge, or the coordination to align Karnak's thousands of standing stones. These projects weren't just engineering challenges, they were social glue, unifying disparate groups under a shared purpose. The very act of construction may have been a ritual in itself, a physical manifestation of communal identity and belief. Then there's the spiritual dimension. The mathematical precision of these sites didn't just serve practical ends, it elevated them to the realm of the divine. Perfect circles, sacred ratios, and celestial alignments transformed stone into a bridge between the earthly and the eternal. At Observatory, the massive henge encircles an entire village, blurring the line between the mundane and the sacred. The stones weren't just tools, they were temples, their geometry echoing the order of the cosmos. For a society without written scripture, these silent sentinels became living texts, their alignments and carvings encoding myths, ancestor veneration, and cosmological truths. The legacy of these gatherings lingers in surprising ways. Modern festivals like the summer solstice celebrations at Stonehenge, where thousands gather to greet the sunrise, echo traditions stretching back millennia. The urge to mark time communally, to gather in the presence of something greater than ourselves, hasn't faded, it's evolved. The megaliths remind us that science and spirituality weren't always separate pursuits. To their builders, tracking the stars wasn't just about predicting seasons. It was about participating in a grand, celestial dance, one that connected the living, the dead, and the gods themselves. In the end, these stones were more than the sum of their alignments. They were stages for the dramas of human existence, birth, death, harvest, and ceremony. They were classrooms where knowledge was passed down, theaters where myths were enacted, and catalysts that transformed scattered individuals into a society. The true genius of the megaliths lies not just in their precision, but in their ability to hold multitudes, to be at once clock, calendar, cathedral, and communal hearth, uniting the practical and the profound in silent, enduring stone. The stones have kept their secrets for millennia, but modern technology is finally prying them loose. Laser scanners and high-resolution 3D imaging are peeling back the layers of time, revealing hidden alignments and carvings that generations of researchers missed. Take LiDAR, light detection and ranging, which has transformed archaeology by stripping away forests and vegetation to expose the bare bones of the landscape. In the dense jungles of Guatemala, it uncovered entire Mayan cities hidden for centuries. Now, that same technology is being trained on Europe's megaliths, exposing subtle earthworks and buried stone rows that extend far beyond the visible monuments. Suddenly, isolated circles like Stonehenge appear connected to vast ceremonial landscapes, their true scale emerging from the shadows. But it's not just about seeing more, it's about seeing differently. Photogrammetry, a technique that stitches thousands of photographs into precise 3D models, has revealed intricate carvings worn smooth by time. At Scotland's Dunnad Hill, a seemingly blank rock face turned out to be covered in faint spiral motifs when viewed under raking light simulations. Similarly, reflectance transformation imaging, or RTI, has brought to life weather-worn symbols at Newgrange that were invisible to the naked eye. These aren't just aesthetic discoveries, they're mathematical clues. The newly revealed carvings often repeat ratios found in celestial cycles, suggesting the builders were encoding astronomical data in plain sight. Then there's the revelation of acoustic archaeology. Using sensitive audio equipment, researchers have mapped how sound behaves within megalithic chambers, discovering that many resonate at frequencies that enhance chanting or drumming. At Malta's Hal Saflieni Hypogeum, a subterranean temple carved from solid rock, certain chambers amplify voices at specific pitches, creating eerie harmonic effects. When combined with 3D scans, these findings suggest the builders engineered their sites not just for light, but for sound, turning stone into a kind of prehistoric instrument tuned to celestial rhythms. Perhaps most astonishing are the digital reconstructions of megalithic sites as they would have appeared millennia ago, accounting for shifts in Earth's axis and stellar positions. Software like Stellarium, typically used by astronomers, can simulate ancient skies with pinpoint accuracy. When applied to sites like Callanish, it reveals that certain stones align not with today's stars, but with constellations as they appeared 5,000 years ago. These virtual time machines are proving that what we once dismissed as rough approximations were, in fact, precise astronomical instruments. Yet for all their power, these tools raise as many questions as they answer. Why did some carvings face inward, hidden from public view? Were the acoustic effects intentional or happy accidents? And how did societies without written language achieve such technical precision? The stones may finally be yielding their secrets, but their full message, written in geometry, alignment, and resonance, remains just out of reach, waiting for the next leap in technology to bring it into focus. Mainstream archaeology paints a picture of Neolithic societies gradually developing astronomical knowledge through generations of observation, patiently noting the sun's shifting path, the moon's subtle wobbles, and translating those patterns into stone. But not everyone accepts this incremental narrative. Some theorists argue the precision of megalithic sites hints at something more extraordinary. Knowledge gifted by extraterrestrial visitors or remnants of a sophisticated global civilization lost to time. The idea isn't new. Swiss author Erich von Däniken's Chariots of the Gods famously speculated that ancient monuments were built with alien assistance, pointing to the sheer scale of projects like the Great Pyramid as evidence beyond human capability. Similar theories suggest megalithic builders inherited blueprints from an advanced culture, perhaps the mythical Atlantis or another forgotten society wiped out by cataclysm. These alternative explanations often hinge on perceived anomalies. How, for instance, could Neolithic people transport 50-ton bluestones from Wales to Stonehenge without wheels or draft animals? Why do sites separated by oceans share uncanny geometric similarities? And what explains the mathematical sophistication encoded in structures supposedly built by primitive farmers? Proponents of these theories argue that mainstream science underestimates ancient capabilities, dismissing inconsistencies as coincidence. They highlight the Piri Rise map, a medieval chart allegedly depicting Antarctica's ice-free coastline, or the Baghdad Battery as proof of forgotten technologies. Yet before we rewrite history, it's worth scrutinizing these claims. Archaeologists have demonstrated how sledges, rollers, and clever leverage could move massive stones, as seen in experiments replicating megalith transport. The shared geometries across cultures, They likely emerged from universal observations of nature's patterns, not a single lost source. As for the Piri Rise map, scholars note it probably reflects pieced-together sailor accounts, not preglacial surveys. The real danger lies in the ancient astronaut narrative's insidious implication that non-Western societies couldn't have achieved such feats independently. This ignores the ingenuity of oral traditions, where knowledge passed down over centuries could achieve remarkable precision without writing. That said, some mysteries still resist tidy explanations. The Göbekli Tepe complex, dating back over 11,000 years, challenges conventional timelines of civilization's rise. Its intricate carvings and massive pillars suggest organized labor and symbolic thought emerging much earlier than previously believed. Could there be grains of truth in the lost civilization hypothesis? Perhaps, but rather than invoking aliens, it's more plausible that earlier human cultures, now submerged by rising seas or buried under millennia of sediment, achieved sophistication we're only beginning to uncover. The allure of alternative theories speaks to something deeper, our discomfort with gaps in the historical record. It's easier to imagine divine intervention or cosmic tutors than to accept how much we've forgotten about our own ancestors' capabilities. But the stones themselves offer a different lesson. They remind us that human curiosity and collaboration, not extraterrestrial handouts, built these marvels. The truth may be less sensational than von Däniken's visions, but it's no less awe-inspiring. Ordinary people, armed with patience and collective wisdom, decoded the cosmos and etched their understanding into the earth. The real mystery isn't whether aliens helped, it's how much more these ancient builders knew than we've yet dared to credit. The echoes of megalithic mathematics resonate through history, threading their way from ancient stone circles to the foundations of classical civilizations. When the Babylonians developed their sophisticated base 60 number system, they weren't working in isolation. They stood on the shoulders of millennia-old traditions of celestial observation and geometric precision. Their famous Plimpton 322 tablet, often hailed as one of the earliest trigonometric tables, mirrors the same Pythagorean triples found in Stonehenge's bluestone arrangements. This isn't coincidence, it's cultural inheritance, the slow distillation of knowledge passed down through oral traditions, trade routes, and shared human curiosity about the heavens. The Greeks, too, owe an unspoken debt to these prehistoric mathematicians. Pythagoras, credited with formalizing the theorem that bears his name, likely encountered these principles during his travels to Egypt and Mesopotamia, regions where megalithic-inspired geometry had already taken root. The Parthenon's perfect proportions, the golden ratio woven into its columns and pediments, feel eerily reminiscent of the spirals carved into Newgrange's stones 2,000 years earlier. Even Euclid's Elements, the bedrock of Western geometry, codified ideas that megalithic builders had already expressed in stone: the properties of circles, the harmony of angles, the language of celestial symmetry. Fast forward to modern astronomy, and the legacy grows even clearer. The design of today's radio telescopes, with their precise parabolic curves, mirrors the acoustic properties of megalithic chambers engineered to amplify celestial frequencies. Archaeoastronomers like Clive Ruggles have shown how contemporary star maps still rely on alignments first marked by standing stones. Stonehenge's sightlines, for instance, prefigure the equatorial mounts used in modern telescopes to track stellar motion. Even our calendar, with its leap years and adjustments, refines the same solstice tracking systems that Neolithic farmers etched into the landscape. Architecture, too, carries this ancient DNA. The geodesic domes of Buckminster Fuller, the fractal-inspired designs of Zaha Hadid, even the spiral ramps of New York's Guggenheim Museum, all whisper of megalithic principles reborn in steel and glass. The very notion of sacred geometry, revived by Renaissance architects like Brunelleschi, traces its roots to those early builders who saw divine order in the angles of stones and the arcs of celestial bodies. Yet the most profound legacy lies not in specific techniques, but in a way of thinking. Megalithic mathematics wasn't just about calculation. It was about integration, a world view where numbers bridged earth and sky, where human structures mirrored cosmic patterns. This holistic approach, now re-emerging in fields like biomimicry and sustainable design, reminds us that the past's most enduring gifts aren't just tools or formulas, but perspectives. The stones taught us to measure not just space, but our place within it, a lesson as vital today as it was 5,000 years ago. The ancient practice of megalithic timekeeping isn't just a relic of the past. It's a blueprint for how we might reorient our modern lives to the rhythms of the natural world. Imagine a society where buildings weren't just shelters but living calendars, where the walls themselves marked the turning of seasons and the migration of stars. Today, as we grapple with climate change and the disconnection wrought by artificial lighting and digital screens, these Stone Age innovations offer surprising lessons in sustainable living. Architects are already taking note, designing structures that harness passive solar energy by aligning windows with winter sun angles, much like Newgrange's roof box. Urban planners in Scandinavia are experimenting with light calendars, public art installations that track solstice shadows, reconnecting city dwellers to cycles older than agriculture itself. Beyond architecture, megalithic principles are revitalizing agriculture. Farmers practicing lunar cycle planting, sowing, and harvesting according to moon phases report higher yields and healthier soil, echoing the celestial awareness of their Neolithic predecessors. In Japan, the centuries-old practice of Satoyama, maintaining forests in harmony with lunar tidal patterns, has been recognized by the United Nations as a model for sustainable land use. These aren't mystical traditions but time-tested systems that acknowledge a truth we've forgotten. Human flourishing is inseparable from planetary rhythms. The stones also challenge our assumptions about progress. We pride ourselves on living in the most technologically advanced era, yet our ancestors tracked celestial events with nothing but stone and patience, and achieved accuracy rivaling modern instruments. This forces a humbling question: what knowledge have we lost in our rush toward mechanization? Indigenous cultures from Australia to the Andes still use oral traditions to preserve astronomical data over generations, proving that literacy isn't the only path to precision. Perhaps the megalith's greatest gift is the reminder that innovation isn't always about moving forward. Sometimes it's about circling back to wisdom buried in plain sight. On a deeper level, these ancient timekeepers invite us to reconsider our relationship with time itself. In a world enslaved by clocks and productivity metrics, the megalithic world, you measured time in seasons, generations, and cosmic cycles. The Maya's long count calendar, which spans 5,000 years, or the Vedic Yuga system, which unfolds over millennia, reflect a patience alien to our quarterly report mentality. Yet as psychologists warn of epidemic burnout, their long-term perspective feels urgently relevant. Companies like Patagonia are already experimenting with nature time work schedules, syncing deadlines with ecological rather than fiscal calendars. The stone's silent testimony also reshapes education. Schools from Scotland to New Mexico are incorporating landscape archaeology into STEM curricula, teaching geometry by measuring stone circles and astronomy by decoding petroglyphs. These hands-on lessons do more than convey facts. They foster a mindset where math isn't abstract equations but the living language of the earth and sky. When students at Orkney's archaeology camps reconstruct Neolithic sundials using only sticks and shadows, They're not just learning about the past, they're inheriting its most vital skill, the art of observation. Perhaps most profoundly, megalithic timekeeping redefines what we consider advanced civilization. We marvel at smartphones but ignore the cognitive leaps required to build Kallenish's Lunar Observatory or encode precession in stone. These achievements suggest that intelligence isn't linear, it's adaptive, flourishing in different forms across cultures and epochs. As we face global crises demanding creative solutions, the megaliths whisper an unexpected truth. Sometimes the future belongs to those who remember how to read the stars. Even with all we've uncovered about megalithic timekeeping, the stones still guard frustrating gaps in their story. One of the most puzzling questions is why this sophisticated tradition of astronomical construction seemingly vanished around 4,000 years ago. The decline wasn't uniform. While Stonehenge's final phases were still being built, other sites across Europe were already falling into disuse. Climate change offers one compelling clue. Studies of ancient pollen samples reveal that the late Neolithic period saw dramatic shifts, with cooler, wetter weather transforming once fertile plains into peat bogs. For agrarian societies tied to solar cycles, prolonged cloud cover could have rendered celestial markers unreliable, eroding faith in their stone calendars. Yet environmental factors alone don't explain the full picture. Archaeological evidence hints at cultural upheaval. The arrival of the Bell Beaker people in Britain brought new burial practices and metal tools, signaling a shift from communal stone raising to more mobile, individualistic lifestyles. But here's the paradox: while megalithic construction waned, the knowledge it embodied didn't disappear entirely. The later Bronze Age Nebra sky disk, with its gold arcs marking solstices, proves celestial timekeeping endured, just divorced from monumental stones. This suggests the decline wasn't an extinction of knowledge, but a transformation, like switching from stone tablets to pocket watches. The deeper mystery lies in what might have preceded these structures. Göbekli Tepe's discovery shattered our timeline, proving complex stone circles existed 6,000 years before Stonehenge. Could there be even older timekeeping sites now submerged by rising seas? Off the coast of Wales, underwater surveys have revealed a drowned forest with tree stumps dated to the Mesolithic contemporary with potentially earlier, unrecorded megalithic experiments. And at Indonesia's Gunung Padang, controversial excavations suggest a pyramid-like structure buried under volcanic ash, with claimed dates pushing back 12,000 years. While these sites are still debated, they hint at a haunting possibility: that the megaliths we admire today are but the survivors of a much older, vaster network of celestial observation, most of it lost to rising waters or geological upheaval. The most tantalizing gaps involve the builders themselves. Unlike Egyptian pharaohs or Mesopotamian kings, Neolithic astronomers left no names, no boastful inscriptions, just anonymous stones whispering of their skills. Were they priest astronomers passing knowledge through oral traditions, or was this a democratized science with entire communities participating in sky watching? The absence of weaponry at most sites suggests these weren't warrior cultures, yet the scale of their projects implies remarkable social cohesion. Perhaps the answer lies in the carvings we've yet to decipher, those spirals and zigzags that may encode not just celestial data, but the very stories of the people who carved them. Every new technology brings us closer to answers. Recent advances in isotopic analysis can trace the origins of stone with pinpoint accuracy, revealing trade routes that may have carried astronomical knowledge. Ground-penetrating radar continues to uncover hidden chambers and buried stones, expanding our map of these ancient observatories. But some secrets may remain locked in the stones forever, like why certain sites were deliberately buried. or how oral traditions maintained precision across generations without written records. These gaps aren't just academic, they're reminders of how much we still don't understand about humanity's first great scientific revolution, and how fragile even the most enduring knowledge can be when faced with the relentless tide of time. You don't need a degree in archaeology to become part of the story these ancient stones are telling. Just curiosity and a willingness to look up. Start by exploring the megaliths in your own backyard. Across Britain, Ireland, and Europe, countless stone circles, standing stones, and burial mounds sit unmarked on hiking trails or tucked into farmland, waiting to be rediscovered. Sites like the Rollright Stones in England or the Dromeg Circle in Ireland are accessible year-round, often with no entrance fee. Time your visit to a solstice or equinox, and you might witness the same celestial alignments that Neolithic builders designed millennia ago. Pack a compass, a notebook, and a camera, modern tools that let you document what ancient observers once memorized. For those who want to dig deeper, citizen science projects offer hands-on ways to contribute. Platforms like Zooniverse host megalithic portal initiatives, where volunteers analyze satellite images to identify potential undiscovered sites. In Cornwall, the Standing Stones Live project invites the public to help record erosion patterns on ancient monuments using 3D photogrammetry, a technique that stitches photos into precise digital models. Even simpler acts matter. Logging alignments with smartphone apps like Sun Surveyor or noting bird behavior near megaliths. Some species nest in ways that echo solstice markers, can reveal forgotten connections between nature and these stone calendars. Local astronomy clubs often host Sky Watch events at megalithic sites, combining stargazing with history. Imagine lying beneath the stars at Castlerigg Stone Circle in the Lake District as an expert points out how the same constellations guided Bronze Age shepherds. Or join a guided dark sky tour in Orkney, where minimal light pollution lets you see the heavens as the builders did, no telescope required. These experiences don't just teach, they reawaken a primal familiarity with the night sky that urban life has dulled. If travel isn't an option, digital tools bring megaliths to you. Google Earth's Ancient Earth layer overlays prehistoric sites onto modern landscapes, revealing hidden patterns. Interactive apps like Stonehenge VR let you manipulate virtual stones to test alignment theories, while open-source datasets from projects like the Scottish 10 invite armchair archaeologists to help map laser-scanned carvings. Online forums like the Megalithic Studies group on Reddit buzz with amateur researchers sharing discoveries, from a farmer in Portugal who noticed cup marks on a boulder in his field to a hiker in Wales who spotted a new solstice alignment using a drone. The most rewarding part, you might uncover something experts missed. In 2019, a retiree named Derek Bullock noticed that a forgotten standing stone in Scotland's Isle of Arran lined up with two others during the winter sunset, an alignment later confirmed by archaeologists as intentional. These stones aren't relics locked behind glass, they're living puzzles, and every fresh set of eyes brings us closer to solving them. Whether you're sketching carvings, measuring shadows, or simply sitting quietly as solstice light spills through an ancient doorway, you're continuing a tradition as old as the stones themselves, the human urge to measure, to wonder, and to leave your own mark on the story of time. Myths swirl around megalithic sites like mist over the moors, tales of alien architects, lost super civilizations, and mystical energies. But strip away the speculation, and what remains is something even more extraordinary, the undeniable proof of human brilliance. Take the claim that Neolithic builders couldn't possibly have moved massive stones without extraterrestrial help. Yet experimental archaeology has shown how teams using wooden sledges, ropes, and log rollers can transport multi-ton blocks across miles, just as volunteers demonstrated in Wales, hauling a Stonehenge-sized bluestone using only Neolithic techniques. The real marvel isn't that aliens did it. It's that ordinary people working together achieved the impossible with nothing but ingenuity and elbow grease. Another persistent myth suggests these sites were power plants or energy transmitters, their stones humming with ancient technology. While it's true that some megaliths resonate at specific frequencies when struck, this isn't evidence of forgotten science, it's basic physics. Granite and limestone naturally vibrate at certain pitches, a phenomenon any stonemason could have discovered by accident. The acoustic properties of chambers like Newgrange likely amplified rituals, turning sound into a spiritual tool rather than a technical one. Modern instruments detect no mysterious energy fields, just the quiet pulse of Earth's own magnetic currents, no different from those surrounding any large rock formation. Then there's the romantic but flawed idea that megalithic builders were peaceful stargazers, untouched by conflict. While no weapons have been found at Stonehenge, other sites tell a darker story. In Portugal's Zambujeiro tomb, skeletal remains show signs of violent trauma, and in the Scottish Orkneys, evidence of ritualistic cannibalism surfaces. These weren't utopian societies but complex cultures capable of both profound creativity and brutality. The stones don't hide this duality, they embody it, standing as monuments to humanity's full spectrum. Perhaps the most pervasive myth is that these structures were built in isolation by primitive farmers. In reality, megalithic Europe was a connected world. Isotope analysis of bones at Stonehenge reveals some buried there came from as far as the Alps, while Baltic amber and Mediterranean shells found at British sites prove extensive trade networks. The shared use of the megalithic yard across continents hints at communication we've yet to fully understand. This wasn't the work of ignorant villagers, it was a collaborative project spanning generations and geographies, a testament to organized society long before written history. The greatest disservice these myths do is diminish the achievements they try to explain. By attributing megaliths to aliens or Atlanteans, we rob our ancestors of their rightful credit. The truth is more inspiring. With patience, observation, and collective effort, Neolithic cultures decoded the cosmos and etched their understanding into the landscape. They didn't need magic, they had something far more powerful, the human mind, curious and relentless, turning stone into a language that still speaks across millennia. The next decade of megalithic research could rewrite history books, thanks to technologies that peel back layers of time without disturbing a single stone. Hyperspectral imaging, originally developed for satellite surveys, now scans weathered carvings at sites like Noth, revealing faded symbols invisible under normal light. In Portugal, researchers using this technique recently uncovered hidden spiral motifs on a men, here previously thought to be blank, proof that these stones still hold secrets in plain sight. Meanwhile, muon tomography, which harnesses cosmic rays to create X-ray-like scans of dense structures, is mapping hidden chambers within Egypt's pyramids and may soon be trained on Europe's megaliths. Imagine discovering intact Neolithic timekeeping artifacts sealed for millennia, their mathematical codes preserved like a prehistoric Rosetta Stone. Groundbreaking work in Archaeocoustics is also transforming our understanding. At Malta's Hal Saflieni Hypogeum, researchers used laser vibrometry to create 3D sound maps of the underground chambers, proving certain niches resonate at frequencies that induce altered states of consciousness. Similar studies at Scotland's Micho show how its passageway amplifies specific vocal tones, perhaps explaining why Gaelic folklore describes these sites as singing caves. Now, teams are developing AI models to simulate how sound would have interacted with missing or collapsed stones, effectively reconstructing lost sonic environments where chants and drumbeats might have harmonized with celestial events. Interdisciplinary collaborations are yielding unexpected connections. Geneticists analyzing skeletal DNA from megalithic burials have traced stone working knowledge along migration routes from Anatolia to Atlantic Europe. At the same time, climatologists cross-referencing ice core data with construction phases suggest megalith building intensified during periods of climatic instability, as if these stones were anchors in a changing world. Even astrophysicists are joining the conversation, using supercomputers to model prehistoric skies and verify whether controversial alignments, like the Orion correlation at Egypt's Giza Plateau, hold mathematical weight. Perhaps most promising are the digital twins being created of major sites, using billions of data points from LiDAR, photogrammetry, and ground-penetrating radar. Researchers at Durham University have built virtual replicas of Stonehenge that can test alignment theories in real time. Adjust a stone's position by a few degrees, and the simulation shows how solstice shadows would shift, a tool that's already debunked long-held assumptions about the heel stone's original orientation. Similar projects are underway for Newgrange and Karnak, creating living laboratories where hypotheses can be tested without risking damage to fragile originals. The biggest revolution may come from crowdsourcing. Platforms like MegaWeb allow amateur researchers to analyze drone footage of lesser-known sites, with volunteers in 2022 identifying a previously unnoticed stone row in Wales that aligns with the winter moonrise. As machine learning algorithms improve at pattern recognition, they're sifting through global satellite imagery for circular formations obscured by forests or urban sprawl, hints of a megalithic network far more extensive than we imagined. Yet for all our technological prowess, the stones still guard their deepest mysteries. Why did cultures across continents independently develop such similar designs? What catastrophic event might the Younger Dryas carvings at Göbekli Tepe memorialize? And how did oral traditions maintain mathematical precision across hundreds of generations? The answers may lie not in flashy gadgets, but in patient observation, relearning the slow, seasonal rhythms that shaped megalithic minds. As we stand on the brink of these discoveries, one truth becomes clear. These ancient mathematicians still have much to teach us if we're willing to listen. The same solstice sunlight that once illuminated Newgrange's inner chamber now falls on a dilemma. How do we protect these ancient timekeepers from the very crowds who come to marvel at them? Stonehenge alone sees over 1 million visitors annually, their footsteps compacting the earth, their breath altering the humidity inside fragile stone chambers. In Orkney, the 5,000-year-old ring of Brodgar stones are slowly sinking into waterlogged ground as climate change intensifies rainfall. The paradox is painful. The more we value these sites, the faster we risk destroying them. Preservation isn't just about locking monuments away. It's about rethinking our relationship with the past in an era of mass tourism and environmental upheaval. Some solutions emerge from the stones themselves. At Ireland's Brú na Bóinne complex, access to Newgrange's solstice event is now lottery-based, limiting crowds to a handful of witnesses who experience the phenomenon much as Neolithic people did in hushed awe without the crush of thousands. Replica sites like the full-scale Stonehenge model at Maryhill in Washington state offer immersive experiences while diverting traffic from the original. But these measures spark debate. Does a copy, no matter how precise, carry the same cultural weight? For the Maori of New Zealand, who have long protected sacred stones like Tokangaha, the answer is clear. Some knowledge belongs only to those who approach with reverence. Their model of Kaishiakatanga, or guardianship, emphasizes not just physical preservation but spiritual continuity, a concept now inspiring conservationists from Scotland to Peru. Climate change presents a more insidious threat. Rising sea levels endanger coastal sites like Scotland's Callanish, where saltwater erosion eats at the bases of standing stones. In Malta, the Halsaflieni hypogeum's delicate limestone carvings are threatened by increased humidity from erratic weather. Archaeologists are turning to space-age solutions, nanoscale consolidants that strengthen stone without altering its appearance, or climate-controlled domes like those protecting Norway's Viking ships. Yet these interventions raise ethical questions. How much modern technology should we inject into ancient structures? At Observatory, where lichen growth on stones is carefully monitored, some argue even natural decay is part of a site's story, a record of its dialogue with time. The most contentious battles often revolve around reconstruction. When Japan's Sanai Maruyama site rebuilt Neolithic pit dwellings using traditional methods, purists called it archaeological Disneyland. But at Turkey's Göbekli Tepe, 3D printed replicas of crumbling pillars allow tactile exploration while shielding originals. Striking this balance requires humility, recognizing that every intervention, no matter how well-intentioned, alters the authenticity future generations will inherit. The 1990s restoration of Karnak's menhirs, which controversially straightened leaning stones, now serves as a cautionary tale about imposing modern aesthetics on ancient intent. Perhaps the greatest challenge is decolonizing preservation. Many megaliths sit on land taken from indigenous peoples, whose descendants are now reclaiming stewardship. In Australia, the Wurdi-Yuang stone arrangement, a potential Aboriginal astronomical site, is managed jointly by scientists and the Wathaurong people, blending satellite mapping with oral traditions. Similarly, Maine's Passamaquoddy tribe advises on the protection of solstice-aligned petroglyphs, ensuring conservation respects cultural protocols. These partnerships acknowledge a hard truth: Western science doesn't hold a monopoly on understanding the past. The path forward lies in seeing megaliths not as relics to be frozen in time, but as living teachers. At Denmark's Mols laboratory, researchers are training memory gardeners to maintain Neolithic earthworks using period-accurate tools, merging archaeology with hands-on care. Schools near Spain's Antequera dolmens teach kids to monitor microclimates inside tombs, fostering a new generation of guardians. These approaches recognize that preservation isn't about resisting change, it's about guiding it, ensuring these stones continue their silent conversation with the cosmos for millennia to come. After all, their builders didn't raise them to be museum pieces, but to endure as active participants in humanity's unfolding story. Standing before these ancient stones today, we're not just looking at the past, we're glimpsing an alternate path of human progress, one where numbers danced with the divine and architecture spoke the language of the cosmos. The encrypted mathematics of megalithic timekeeping forces us to reconsider what we call advanced civilization. These builders achieved celestial precision without writing systems, moved mountains without machinery, and engineered monuments that outlasted empires, all while maintaining a harmony with nature that our modern world struggles to replicate. Their legacy isn't just in the stones themselves, but in the radical idea that science and spirituality weren't opposing forces, but complementary ways of understanding a universe far more interconnected than we often remember. Think of how we mark time today: digital clocks counting microseconds, atomic precision divorcing us from the rhythms of sunrise and seasons. Contrast that with Newgrange's roof box, where a single beam of solstice light became the year's heartbeat, or Stonehenge's lintels framing the moon's slow waltz across generations. These weren't crude attempts at timekeeping. They were sophisticated technologies of memory, designed to keep human lives synchronized with cosmic cycles we've only recently relearned through satellites and supercomputers. The quiet genius of these structures lies in their patience. Their builders thought in scales that spanned lifetimes, crafting calendars that would remain accurate long after their names faded from memory. Yet the stones offer more than historical insight. They challenge our assumptions about progress itself. While we've mastered splitting atoms and sequencing genomes, we've lost something these cultures nurtured: the art of collective observation, the transmission of knowledge through story and symbol, the ability to see mathematics not as abstract equations but as the living fabric of the world. Modern experiments prove this wasn't mystical intuition but rigorous science when volunteers replicate megalithic lunar observations using only sticks and stones. Their accuracy rivals modern ephemeris tables. This suggests an uncomfortable truth. Our ancestors weren't primitive. They were differently advanced, their intelligence honed by needs we've since forgotten. What makes these discoveries so thrilling is their unfinished nature. Every year, new technologies reveal fresh layers of meaning: LiDAR uncovering lost alignments, acoustic software detecting hidden resonant frequencies, isotopic analysis tracing the epic journeys of individual stones. The recent discovery of a potential megalithic grid linking sites across Europe hints at a prehistoric network of knowledge sharing we're only beginning to map. And with climate change exposing previously buried sites, like the 4,000-year-old circle emerging from a Welsh reservoir, we're reminded how much remains hidden, waiting to reshape our understanding of the ancient world. Perhaps the most profound lesson lies in how these builders encoded their wisdom. Unlike our fragile digital archives, vulnerable to bit rot and format obsolescence, their stone libraries endure. The same spiral carved into Newgrange appears in petroglyphs from Arizona to Azerbaijan, suggesting a universal language of symbols transcending cultures. These patterns whisper of a time when education meant sitting beneath the stars, learning to read the sky's mathematics as effortlessly as we read street signs, a literacy not of letters but of light and shadow, of angles and alignments woven into the landscape itself. As we walk away from these silent teachers, their challenge lingers. What knowledge are we leaving for future generations? In an age of climate crisis and short-term thinking, the megaliths model a different approach, building for permanence, aligning with natural rhythms, thinking in spans that dwarf individual lifespans. They remind us that true innovation isn't just about moving forward. It's about remembering, about recovering lost wisdom that might light our way through tomorrow's uncertainties. The stones have kept their secrets for millennia, but now, as we finally learn to read their encrypted messages, they offer something priceless, not just a window to the past, but a compass for the future. Your turn. Have you visited any of these sites? Did you notice alignments or patterns the guidebooks missed? Drop your experiences below, and let's keep the conversation going. For more journeys into humanity's hidden histories, hit subscribe. Who knows what other forgotten marvels we'll uncover